evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com workshop, brought to you by TechStrong and Sonatype. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting workshop ahead, but first I have just a couple of housekeeping notes to cover. First, today's workshop is being recorded, so if you happen to join us late or you have to leave us early, you can rewatch. The recording will be made available shortly after we conclude, and we'll also be sure to send that to you via email. There is a Q&A tab on the right side of your screen, and that's where we want you to send any questions you might have for Sal today. And then we also just have a chat tab on the right side of the screen, and that's where we want you to engage with one another and just let us know from where you're tuning in. At the conclusion of this workshop, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around until the end. And let's go ahead and kick off our workshop. The title is Culture Clash on PagerDuty, Why DevOps, SRE, and Cybersecurity Cultures Differ. And I'm joined today by Sal Kimmick, Developer Advocate at Sonatype. Sal, thank you so much for being here with me today. I'm going to give you the floor so you can use all the time that you want.
Excellent. All right. Well, thank you everyone for tuning in today. I'm excited to give this talk. So I've been a part of DevOps, SRE, and cybersecurity teams. And as a machine learning engineer by training, my work really has intersected all of these. I'm really excited to talk to you today about some of the problems and some of the solutions that we can give. Now, this is going to be a longer talk. So there's going to be 2 parts to it. The first one is really how SRE or site reliability engineering has evolved over the last 10 years. And the part 2 is going to be about how cybersecurity is kind of going the same cultural evolution inside of DevOps and what we can learn from SRE in order to incorporate that really well. And then the last part of this, the really tiny last part of this, I'm going to tell you how you can bring everything together and make it fun for your developers. Because I think you can. So this is going to be a really exciting talk for me. It's going to take about an hour, but do put your questions into the chat as we go. I will address them at the end, and if it's a really interesting question, that could become its own talk. That's how this one came about. So in part 1, let's cover what SRE monitoring and observability mean, what DevOps and SREs really look like in the wild, and why there's information silos. And then in part 2, I'm going to go over a little bit about how Log4j gives us a really good exemplar of how these communication dynamics need to change. And then I will give you some good tools and good resources to be able to actually put all of this into action. So let's dive in. So let's define everything up front. When I'm talking about SRE, Site Reliability Engineering, this was pretty well defined by Ben Traynor. So this really came out of Google's SRE team, and he describes it as what happens when a software engineer is tasked with what used to be called operations. If you are a DevOps engineer, you might be a little offended by this because you probably would define yourself in the same way. But it differs a lot because of the way that we use monitoring and observability. So if I'm going to talk about monitoring today, this is enabled by building telemetry into your system. So we want to be able to look into our records. We want to look into our runtime. We want to look into what types of open source we are bringing in, for example. Everything that allows us to build what you would basically need for a nutrition label on the back of your software can be done with monitoring. And then second is observability. And that's a little bit different from monitoring, although it relies on monitoring. So observability is a property of a system. So you can monitoring a system can be done with instrumentation, but observability is really doing this in an incredibly mindful way. So we are in the age of dashboard monitoring. And the difference here is good observability is choosing what are the right things to pay attention to, what is the right combination of things to pay attention to. And that's what I'm really excited to get into at the end of this talk for good observability. Observability has changed a lot in the last 10 years as we've moved primarily off of monolithic architectures to microservices. And increasingly, these microservice architectures are made available by resourcing from open source. So some of the metrics that I'm going to strongly suggest here really come from the change in the way that we deliver and absorb software and why we need to think differently about it. So, observability, basically defined, I think we all understand, but observability done well can be a different story. All systems observe the laws of thermodynamics, and this includes software, not just your software, the hardware underneath it. Even the most stable architecture that we can all develop will decay in some form. Now, the two forms of decay that I'm going to talk about in the first part of this talk, we're going to use the SRE definition. This is really, is my runtime available? Is it working? Do I have outages? And the second part, we're going to talk about observability of your open source software and some of the issues that we're coming to see here and how reliable that can be to depend on. So observability, very basically, is the signal processing of a state of a system that will, and this is true, will continuously change with use and decay over time. So when we're discussing the SRE domain, I really observe this to be part of DevOps, and I've got some statistics to back this up. So DevOps can be really well defined as the combination of development and operations, really putting them together in this beautiful image that I'm sure we've all seen before, that is CI/CD, so continuous integration and continuous delivery. Within that, we need to monitor, operate, deploy, release. We also, on the other side, when we're not in production mode, need to take the feedback from those spaces and understand how we want to plan, code, build, and test. So when we're thinking about this, I've really been curious about the adoption of site reliability engineering within large and medium-sized enterprises and understanding what they think about it and how they're utilizing that as a practice for good development. And I think what's really interesting is that we've observed that only 64% of respondents indicate that the SRE role has existed in their companies for 3 years or less as of 2021. I think this is fascinating because it means that a lot of our sort of DevOps environments are still using a more traditional mode of development that may not be mature enough for the modern reality that we're sitting in. Now, of the same study, again, this is our, so this is the DevOps and SRE study from 2021, 41% of respondents indicated that they would view their SREs as part of the same team as DevOps, meaning almost 60% view both the development of the software and the actual monitoring of its runtime and operation and production as separate processes. I don't think this is a very intelligent way to work, and I'd like to see this improved over time. Increasingly, I do want to see SREs embedded inside of engineering teams, and this is the argument that I will make in part 2. We also need to be seeing this for cybersecurity as well, because of the way that this open source supply chain is changing the way that we need to make decisions as developers. You need that intelligence, you need that specialization, you need that opinion in the room while you're making those initial decisions. Both SREs and cybersecurity should be embedded inside of your developer teams. So right now, if you ask a mid to large size enterprise which of the following metrics they are tracking, the majority of them are tracking error rates, end user response time. Some of them are tracking mean time to response. I really need to see this improved because it's incredibly important. That mean time to response doesn't just impact your uptime, it impacts the actual value of your product to your end user. Mean time to detection of an issue is even less well recorded, and the error performance budgets are one of the least often utilized aspects of site reliability engineering for an enterprise. All of these metrics are useful, but if you were doing this intelligently, you would almost see this graph inversed. The error rate is important, but it doesn't give you as much information as your error performance budgets. In this case, that's because we are looking at the difference between uptime and downtime, or we're trying to observe if you are dealing with something that is sitting on the cloud, a lot of different variabilities of the layers of architecture behind that. There's a lot of reasons why you could be having error performance issues. And if you allow yourself to have a budget, you can start to look at this and understand, do I need to have a little bit more of a budget? Do I need to have more nodes, more availability in a certain space for a certain time? It's making that difference between just doing monitoring and doing intelligent observability that would really turn this around. So when I'm talking about error budgets, these are simply the amount of error that a service can accumulate over a specified period of time, typically before end users grumble about the experience. Now, this is incredibly important. It's not about having the best uptime that you can have no matter what. That's not essential, and that's probably a pretty poor choice of building architecture and putting your monetary resources towards. You want to have whatever is minimally sufficient in order to provide your end user a good experience. Now, if you're building for that, then you're building architecture which is driven by business intelligence, and that's what we all want to be doing. So error budgets are incredibly important, and you should be utilizing them. A couple important things to understand when you're making that transition from traditional DevOps to a combination with SREs are these three. When we are doing best practice here, keep these three things in mind. The bigger the silos, the more lines of code are going to be needed to review to resolve the bug. This is why I'm making the argument in this case that we should be seeing more SREs embedded into developer teams and more cybersecurity expertise embedded into developer teams. Now, the inverse of this is true. The smaller the change, the faster the fix. This is a good way to prevent rollback panic or merge fires. I don't know how long all of the audience has been in development, but I have been part of Friday evening merge fires, and this is a really good way to avoid them. We have a lot of good automation that has come into place in the last few years. GitHub has done wonders in the ways that they're allowing us to prevent these kind of disasters, but they still do occur. And gradual, meaningful change is the goal. But as we get further into this talk, I'm going to explain to you the ways that cybersecurity is kind of changing the game here, because the assumptions that site reliability engineering was built upon didn't really account for a slightly more chaotic open source contribution of code that can introduce cybersecurity concerns at a rate and magnitude that we have never seen before. So I get this question a lot. Is SRE just better monitoring and automation? And if you can tell from the tone of my voice, the answer is no. So it's a very different way of looking at development and doing development where you're recentering the focus around business intelligence, around your end user, and making sure that you're providing a good experience, not about building just optimal architecture. Optimal architecture is only as good as the value to the end user. So monitoring and automation helps us to put the health of your services at the center of your business strategy. Now, this is a lesson that we've learned really well in SRE, but we need to learn this and we need to understand this for cybersecurity, because the siloing of your security research teams is probably creating a really, really big chasm in the business intelligence and the capacity to develop around what is good to bring into your source code. And again, my last note here, this is my, hill I will die on for SRE. What we really want to focus on is the reality of user experience. Now, this gets bent a little bit if you are developing, for example, developer tools, because we have to expand the reality that we're dealing with to understand that they are just as aware in these days, or becoming more aware of when open source breaches, open source malware, open source ransomware becomes an issue. So we want to be able to address that in real time. And we want to make sure that we have SOPs in place. We want to make sure that we have a process in place that accounts for them. So I'm going to go into a little bit about how to do SRE well. I'm not going to go into a lot of detail here, but there's a couple of things that we need to define. Thankfully, they're really easy to understand. So if we want to do SRE, right, both the measurement and the observation, we want to do this quantitatively. And this is how we do this. So there's 3 things to keep in mind here. A service level indicator, so an SLI, is the statement that X should be true. So my runtime should be active. I should not have outages. A service level objective is Y% of time. So this is why you'll see a lot of companies riffing off of the sort of all of the nines. So you can have something that is like 99% available or 96% available. That's giving a little bit of leeway to the reality of the fact that we have software that's working on hardware that's often working on cloud servers that we don't have complete control over. You are never going to have 100% availability. That just is not possible. Again, the laws of dynamics make that impossible. So it's really good to have reality written into the way that you do your operations for development. Now, the last one is an SLA, so a service level agreement. I say here that a service level agreement is the or else statement because it's something that developers don't typically have to deal with unless something goes really, really wrong. But these are usually the legal requirements that you have, particularly if you're dealing with a cloud service provider, for example. You will have SLAs in place that demand a specific amount of uptime and specific SLO in order for you to be able to match your architectural requirements to service your end user. So if we are talking about SLOs now, a percentage of the time, an SLO of 99.95 availability. Let's talk a little bit about this. This seems like it's nice. It's something that we definitely want to have. But that means that you only have 21 minutes and 54 seconds of available downtime for a given service over a 30-day period. This is when we need to talk about error budgets and how to utilize these well. So an error budget quantitatively is, again, thankfully very simple. It is just 1 minus your SLO. So it is the exact inverse of the amount of time that you will allow a service to be down. Now, you don't have to get this right away. This is something that you can initially define and then work with your DevOps team, work with your cybersecurity team to make a system that is representative of the reality of how available your system actually is and what is actually necessary for good performance. What if you do have downtime? If it's downtime during a time period, now this is slightly unlikely, but if it's during a period where you don't have a massive surge of end users, that's not a problem. You might want to be instead working on an SLO that sort of has a shifting time box, or say that your SLO is dependent on the specific time periods where you need highest availability for your biggest surge of end users. That's super important because a lot of times I see people getting bogged down in the quants, but not really considering qualitatively if improving a service or putting more money towards availability is going to solve a business value problem. So incorporating error budgets is a fundamental part of your developer culture. So it does a lot of things for giving developers breathing room. So both on the DevOps and the SRE side, it makes a big difference. For developers on the DevOps side, this means that you can really do acceleration of your features in the way that you want to. You can experiment, you can bring in testing modules, you can try to see what works and what doesn't. But if you see a big variability in your SLOs or your SLIs coming off of that, then you will need to backtrack. But again, as we mentioned before, it's these small gradual changes that allow us to do small vectors on a roadmap and really provide good value. This is why a error budget and a culture around good error budgets that are continuously redefined build trust around timely innovation. These are so useful, and I've seen these work. So the goal here is to automate, monitor, and evolve. there's a couple of things that are really essential if you want to put a good SRE practice in. And again, it's good to hire a good SRE, either individual or team, but these are practices. That's all they are. You can be incorporating these as developers, and all the tools, all the information that I'm giving you today can be used as an individual developer or as a team in order to put best practices into place. So if you want to do SRE well, even if that is not your job title, you probably want to consider it. There's a couple of things that you want to keep in mind. So, number one, and we're going to revisit this when we talk about cybersecurity, tell a story with composite SLOs. So, using two or more system level objectives from different services will allow you to provide an end-to-end view of product reliability. This is often, in the traditional SRE space, availability and latency. I'm going to talk about a composite of SLOs that we could be using for cybersecurity instead in the second part. SLO violations are opportunities. When you see that error budget go red, not a problem. You want to have a process in place for immediate action. We refer to this as an SOP. And you want to review all the incidents in a time-locked report for holistic system-level insights. But let's consider the inverse of this. If you do not have a culture of being able to make mistakes when we recognize and we acknowledge that we're building software over hardware and that the laws of physics are our fundamental constraints, there are going to be outages. That is unavoidable. We want to understand how to mitigate those well. So as long as we're monitoring this and observing this well, you're going to be better able to deliver good SOPs that allow you to mitigate the damage, communicate well to your customers if needed, and to move forward with a plan of action that makes sense. Error budget blowouts are good things. You need to have an error budget in place, but when you have a blowout, that just means one of two things. Something went terribly wrong and we need to fix it, or the real answer in a lot of cases is something went wrong, there was an outage, there was an issue, but we didn't see any customer complaints. That's really good news. Is that a place where you can possibly spend a little bit, you can definitely spend less time on development in that space because there doesn't seem to be a business value to it. But can you possibly be putting less money towards resourcing in those areas if it doesn't prove to have any value to the outcome of your end user? This is really what I'm trying to communicate with your error budgets. You should be considering this and moving them around. And if you have an outage, no one complains, make that error budget bigger. Make it so that developers don't need to spend time on something that isn't a business driving problem. Now, lastly, when you work in this way, I know that a lot of us have dashboards that show us all of this monitoring these days, but we really need to think about it about good observability. If you're doing observability well, it allows you to communicate the big picture both up and down to other developers, to your own developers, across teams, but especially up. So you want to be able to ask your team when they're reviewing their SLOs, have we monitored the right things for observability? Do we want to try monitoring new things? Or is there a better composite that would allow us to really get that end-to-end understanding and then to make those changes typically on a quarterly basis? So I've gone into a little bit of details about these, so I'm going to sort of run past these 4 slides, but I make this slide really big because this is so important. And I've made this point, but error budgets are the magic of SRE. They're the thing that we should be taking culturally into different spaces. And I think error budgets for cybersecurity are where it gets interesting because you could have some error budgets, and we'll talk about some quantifications that we can use for these, but there is one place where error budgets do not work. Error budgets do not work if you have a severe vulnerability in your code from open source. That is an issue because as soon as a CVE, a severe vulnerability, is made public, you can be under attack. Now, this is important for big enterprises, but also mid to small enterprises. It is true that mid to small enterprises for SaaS are more likely to go under in the next 12 months after a cybersecurity attack than any other. Cybersecurity attacks like ransomware are something that you typically cannot even get good business insurance for. So you really want to be aware of those, and you cannot build a good error budget around severe vulnerabilities. When you have a vulnerability, you need to take care of it. And that's why I want to remove us from this idea of cybersecurity being a different team, SRE being a different team. We can have error budgets for availability, but not for some of these bigger issues that are becoming more important. You need to catch them before they go into your source code. So the point for error budgets is not to never fail, it's just to fail in a measurable way, and then to change your standards to match the reality of your end users. But there are areas where we will never be able to use error budgets, and cybersecurity for some of these severe vulnerabilities is one of them. So a development team can spend their error budget however they feel is right, either in the prevention or cure of system instabilities. Now, this is really important because when you fall under the line, when your error budget goes red, you have to immediately attempt to address that issue. So as long as that error budget is still clean, still green, that development team has the right, and this is the fundamental part of having trust in innovation for developers. That team has the right to self-define the roadmap around that feature, around something that's, going to build out, make that feature stronger, or attempts to do prevention of system instabilities moving forward. When you do error budgets really well, DevOps teams and SRE teams genuinely get along. When you do not do these well, that's where I can tell. So one of the first things that I will typically do if I am intervening in an enterprise will talk to the SREs. And as stressed as the SRE lead is, that's pretty much equivalent. It's a perfect proxy for how stable the architecture underneath it is. And that is a very good proxy for how genuinely able a development team is to accelerate their features. Again, when we're talking about trust, this is not a kumbaya definition. This is quantitative trust. This is knowing that I can continue to move forward on a roadmap, build out features, and it will not break the system. Error budgets demonstrably balance system stability with new development while keeping end user as the definition of good. I know I just read the slide, but I needed to say that one more time because I think this is the most succinct way to explain why this is so important, why we need to break down these information silos using quantification and observability that allows everyone to understand where and why development is happening on the roadmap. So, traditional SRE, again, it's only about 10 years old, but I would say that it's a little bit more reactive than proactive. Now, when we're talking about open source supply chain issues, when we're talking about the cybersecurity issues that come in, we have to move to something a little bit more proactive. So let's talk about what the difference is between both of these before we move to part 2. So, again, we've talked about SLAs, service level agreements. Now, MTTA and MTTR are very, very important. So this is the mean time to acknowledge an issue. Way more importantly, the mean time to resolve an issue. And the severity of the business impact are directly related here. So I'm providing you an example of how you'll typically quantify the MTTA or MTTR under a service level agreement. Now, this is something to keep in mind if you have clients with whom you have SLAs. It's also incredibly important to keep in mind if you have a cloud service provider, for example, with whom you have SLAs. They will typically tell you and communicate with you about a severe outage, but you want to make sure that you understand these and that in some way you're quantifying these for yourself, because you need to understand how much that outage, that downtime actually impacts your business value to deliver what your product is to your end user. So when we're doing this in a reactive way, we're typically going to put a SOP in process. So damage has already been done. We've got an outage, or as I'm going to discuss later, we have a cybersecurity concern. We're going to go through a couple of standard processes. Is this, one, a known or unknown issue? Is this something we've encountered before? Do we have an idea where in the code base it sits? Or is this an unknown, and do we need to do a lot of exploration in real time while we don't even have our product possibly running? Then we're going to do a criticality analysis. And again, this is where I'm talking about how much this impact the availability and the experience of your end user. That is where you will make the decision of whether or not you need to disclose this to your end user. And again, this gets a little bit more complicated when you're talking about cybersecurity concerns. We'll then do a severity analysis, exactly how many customers were impacted, what was the surface area of the damage done, and then the notification of stakeholders. So you may have a legal requirement to disclose this. Now, all of this pathway, if this sounds stressful to you, this is what pager duty is. This is, and I know none of us have pagers these days, but typically you will have an SRE and a cybersecurity person on what we would call quote unquote pager duty, because you need someone available at all times in large and mid-sized enterprises for the possibility of something bad happening. And then they're responsible for putting the system into place. It is never an individual that's handling this. Ultimately, if you have a good SOP, you already understand who needs to be communicated with, who needs to be brought in, and how you're going to handle this as you move forward. And this is why we do tabletop exercises in cybersecurity, and in SRE, we do game days. So you really can get a good SOP and process just by imagining and devising and attempting to understand these things. Now, I personally, having been on all of these development teams, will say, do not do tabletops or game days without good reason. There are enough genuine, real experiences of having to deal with these that you're probably going to be running into these in real time in your real production. It's just the way that everything is accelerated. I like to say these days, yes, we can be agile, we can have Kanban, but don't assume that the hackers on the other side don't also do agile. They're pretty sophisticated and they've got more motivation than you do to understand your code. So we want to move more from this reactive way of working, and even your tabletops and game days are what I would call reactive. And you're exhausting your developers in the process, right? Making them do false practices around something that they know is not going to do true risk mitigation. But if we can change our mindset here, we can go from reactive to proactive. In this case, we want to define our alert parameters, our severity, our threshold, our frequency of occurrence. Again, what I'm really telling you about this is moving from monitoring to good observability. Then you need to delegate the alert recipient. So what exactly is the chain of command that's going to deal with this and deal with this intelligently in order to get us to that resolution as soon as possible? And then always you initiate that standard operating procedure. Now, this is something that we need to talk about and think about a little bit more for cybersecurity, because this SRE idea of monitoring, observing, and making that part of the CI/CD process is something that cybersecurity has not culturally traditionally been a part of, but it needs to be. So SRE monitoring generally, it goes under these 5 functions: security, system health, app availability, and databases. I am not going to cover all of these today. That is a completely different talk. But I want to talk a little bit about the highest level of thinking about this for your business value for security. Now, there's lots of resources that are available for this, but when you have KPIs, these are really the North Star for what you want to be able to ensure that you are handling well. If you're doing this predictively, you are already really considering what are your credentials, what is your infrastructure access, what's the phishing attack pattern, is there access from unusual locations? Unauthorized deployment should be a big red flag for you. API access incidents and intrusion attempts. You want to be monitoring this. You want to be really aware of this. You want to be observing these. And at any point, if you have something that blips up for you, even if you do not know if it is a concern as something that you should go into a like full-blown SOP. You should be dealing with this. And so there's a lot of really good ways to monitor this. But again, this is my only slide where I would really be talking to a developer in this case. What I want to be talking about today is sort of the cultural and operational level of how to do this well. I've got a completely different talk if you want to go over KPIs for this. But last thing I really want to talk about here is at the end of this session, and I'm speaking fast because I want to get you as much value as I can. I'm going to talk about how you can use Sonatype Lift as a really, really cool way to maybe remove one of those risks around open source security and really mitigate entirely one of the major reasons why we're seeing acceleration fail on DevOps teams, and it's the new cybersecurity concerns. So that brings us to part 2. As I promised, here's what we're going to learn today. We're going to talk about why there's a new wave of cybersecurity attacks, where these vulnerabilities are entering your supply chain and into your source code. I'm going to use the example of Log4j on how this impacted supply chain management. And then I'm going to talk about why Mttu, so mean time to update, is a really, really good SLO to use as a composite to be able to be monitoring, but better than monitoring, observing cybersecurity as we move into a new world where it's not just CI/CD, it's continuous security. And if you've seen this talk before, fear not, I've taken out a lot of the slides. We're not doing a deep dive into Log4j. We're just going to use it as an example, and then we're going to move on to exactly how you can use this in order to create really good observability models. So I am talking today from Sonatype, where we really focus on the open source supply chain. So when I'm talking about that, this really takes a couple of parts here, but you're probably familiar with this no matter where you sit on a developer or management team. So you are typically pulling in open source components. These are open source packages from Python or Java or Golang. You're pulling those in to a source code. That is what makes the composite of what is your SaaS product or your application. Typically, you're going to be containerizing this, and if you're doing this with best practice, you are using infrastructure as code in order to make sure that you can scale these and monitor really using infrastructure as code. This is really important because this monitors your usage in a way that you can really well scale. So at Sonatype, there's a reason why I have the stats that I'm about to show you. That's because Sonatype has been at the forefront of open source and the supply chain for over a decade. So they were the original maintainers of Maven Central. So this is the repository for which all Java packages go in. If you are working in a different field, so PyPy or PyPI, as I have learned on the fact sheet is how you're supposed to say it, is also a repository for all Python packages. These fall under the umbrella of language ecosystems. So there are contributors that bring in their new open source and these repositories that take it in and try to verify it. What Sonatype is doing is creating a layer of protection, a membrane of security protection around that repository, which really, really changes the game. It is not intelligent and it is a poor use of human resources if you're trying to do security monitoring as an individual developer team. How much more effective is it if you can go to the Maven Central repository and know that there is security monitoring in order to make sure that all the packages that are made public there are verified and valid and reliable and free of vulnerability concerns to the best of our ability. This is what we're also trying to do for other language ecosystems as well. It's why I moved to Sonatype. I think this is a really cool way of making sure that human resources are used intelligently and that developer teams can be reserved for building new products, for working on innovation, because security concerns get in the way of innovation. And I work in open source because it's incredibly exciting to see the almost limitless potential of human creativity just imbued by code. So why is this such a big problem? Yes, you may be an enterprise. You may have your own source code. You may have business intelligence. You may have aspects of your code that you did genuinely develop yourself. But it is true that statistically, on average, over 90% of modern application components are open source. So most of what you are pulling in order to create the foundation, the building blocks of your microservice architectures are open source. And if you're a developer, I don't need to make this argument to you. It seems like it's an incredible number, but it's absolutely true. You know that what you do at the beginning of your files is import. This is exactly what that means. It is also true that to some degree, open source is just coming out of the beginning, out of an initial renaissance where people were doing this because they wanted to make things that solved their own problems. Problem is, we've moved into a space where a generation of developers has been unsupported by enterprises, but still providing genuine business value. So I do love this XKCD that, all modern digital infrastructure is supported by some random project that 1 to 3 people are maintaining and have been for 20 years. This is true. And we need to be working on solving this problem. Otherwise, this is not just a call for empathy. This is a call for realism about the fact that if 90% of your software comes from open source, what that means in reality is that 9 out of 10 of the developers that built your application are not on your payroll. They are out of your control. And if they decide to retire tomorrow, there's nothing stopping them from doing that. If they decide not to maintain that code, if there is no one in place to maintain that code, yes, you can fork it, you can pull it, you can maintain it as your own. But that's a very different reality from what we're actually relying on open source for now. And this is not slowing down at all. I think this is what's so interesting. This is one of the most exciting statistics that I saw from last year's open source supply chain analysis. So this is a look at year-over-year downloads of packages for some of the most major ecosystems. So just last year, we saw anywhere between a 50% to 92% increase in the downloads of open source packages from different ecosystems. So when we're looking at that 90%, we're going to see that improve. We're going to see that go up. It is the case now that you are not hiring developers for their ability to develop original code. You're typically hiring a good developer for their ability to integrate other people's code and then to be able to maintain that. Unfortunately, as I said before, when we're looking at cybersecurity issues, it is not true that a hacker is someone in a black hoodie in a dark room somewhere. These are pretty sophisticated attacks because they are incredibly motivated. If they can put out ransomware, if they can get a return on the value for their engagement, they're going to do that. And we are seeing that now. So in these different ecosystems, almost anyone can contribute packages, and there's lots of ways in order to put in cybersecurity concerns here. In this talk, I'm not going to go into a lot of the details of the specific types of cybersecurity attacks, but do a quick Google of my name. It will come up and we will talk about those. Log4j is just one example. But between 2020 and 2021, there was over a 650% increase in supply chain attacks, meaning they're not trying to get into your enterprise architecture anymore. Yes, you might get like phishing emails. Yes, some of these things still happen. It's much more likely that they're just going to go and find one of the most common open source packages for enterprises and attack that. It's less secure and it gives them a blast radius that's much, much wider. It's a much better return for their time. And this is exactly what we're seeing in the statistics. So in every major ecosystem, it's not the case that they're going after, an under-maintained repository. they are going and they are making an attack on the most popular downloaded packages that we utilize. And this is true across every single ecosystem. So it's the things that we depend on the most for business intelligence that are most likely to be vulnerable. Now, this is where it gets really interesting, because remember when I was referencing back to error budgets? This is a space where we can and should also be expecting, just as we can expect outages, expect, plan for, know that you're going to have cybersecurity concerns moving into the new age that we're moving into. It's exploding. It's incredibly easy for anyone who has malintent or bad intent to get focused on delivering injury to enterprises using the supply chain as their primary vector. We're improving this right now, but for the next 2 to 5 years, this is really the forefront of where the issue is for your developers. And this is why we need to rethink what developer culture looks like if you want to have your systems running, your development accelerating, and your culture is still something that people are happy to be within, right? Because developers just want to live in reality. And this is a couple of statistics where reality is really looking down at your nose, right? Like, this is something we all understand. So I'm going to go into very quickly the log4j example, but what I'm showing you here is Sonatype's vulnerability timeline. Point that I want to make here is that log4j was not exceptional. It just happened to get, one, yes, we all relied on it for logging, and it was not just Java, right? Everyone that runs on Golang as well used log4j or log4shell. But what I'm showing you here is the last maybe 6 months of really severe critical vulnerability concerns. These are across different sectors, these are across different languages, and they're all really unique and creative, because not only does a bad actor or a hacker in cybersecurity need to be creating a new or novel way of doing this, there's also a little bit of ego to it as well. And what I've learned in cybersecurity is that they're going to try to make it interesting. They're going to try to one up not just the white hat hackers, but they're going to try to make themselves stand out in a hacker community as well. So what can we do if we are depending on a supply chain in which the fundamental components of what we're receiving might be covered by some random person in Nebraska who's been maintaining it for 20 years? Log4j is a really good example of this, but I want to be clear here. The maintainers of this repository did everything right. I was following this in real time. Again, this happened in December of last year. They were making updates on New Year's. They did not take vacations. They saw this issue. They understood how essential they were to enterprise, and they took action. So if you want to understand just very quickly, and again, we're not going to go into details here, this is why this vulnerability was so bad, so critical, a critical of 10 out of 10. So log4j has two different sort of aspects to it that are important. So log4shell is a Java naming and directory interface, so JNDI. This allows for the unauthenticated remote code execution. So the issue here is that we had a basic logging function, but as soon as it hits JNDI, that allows for execution. So by using just this simple insert of executable code, you could put in, you can pull out databases, you can pull out information. We've seen ransomware attacks based on that. You can also put in a sleeper cell of an executive file. We have no idea how many exec files are still sitting out there for those who have not updated from log4j. This is so scary because of the severity and really how incepted this can be inside of your code if you do not clean it up. And the sort of bigger issue here is sort of two. This comes from the Java language, and Java is very easy to serialize. And if you want to deserialize it, it can really impact sort of the runtime of it. It can really impact how long it takes you to be able to construct it or to be able to break it back apart. So this is really fundamental, partly to the semantic way that Java is set up. But this doesn't mean that something like this might not be coming up in another ecosystem soon. We just haven't seen it yet. And it just takes a very creative hacker in order to show us what the next one will be. So a little bit about what culture looks like in this case. So I talked about DevOps and SRE. Let's talk about what this looks like when we have log4j. So in a traditional setting, these would be pretty informationally siloed because you've got different KPIs, you've got different business intelligence, business value that each of these different teams is trying to pull out. So for a developer, I just want to know how hard it's going to be to upgrade it. And if I need to replace it entirely, then give me a little bit extra time in the next sprint. If I'm in operations, I do need to know where we have it running and is it still running. Security, how are we going to mitigate this? Do we have a process in place? Do we have something else to use? Do we know that that alternative is also not vulnerable because secondary attacks can also be an issue? Legal really only cares if FTC is going to come after us. Again, this is the SLA level of are we not able to meet our agreements for our clients? And DevOps wants to know where in the software delivery lifecycle it's being downloaded. Where do we need to pull this out? Are we going to have production issues as we try to do that? But Log4j was a really good example of what cybersecurity now looks like. So we had an initial severe CVE, and then we had another, and then we had another, and then we had another, and all of this happened in the course of a few weeks. Now, unfortunately, if you have the traditional silo where you've got error budgets, this kind of still works. So I'll jump back to this slide. This kind of still works culturally. If you've got DevOps and SRE separated, there's a little bit of time to response. But if you don't have at least cybersecurity intelligence, if not a cybersecurity engineer embedded inside of your developer team, there's absolutely no way that you're going to be able to deal with these in real time because these are happening inside of a sprint if that's how you're working. You are going to have to stop your development on new features every time one of these new things comes in. And that's just working in a cybersecurity model that's reactive, not predictive. And at the end of here, I'm going to show us, and I promise you there are solutions to this problem, an example of how we might move from reactive to predictive in the cybersecurity space. My last note on this is because Sonatype is the original creators of the Maven Central repository, we've got access to the real-time updates of how many vulnerable versus non-vulnerable versions are being downloaded. Now, this is what really blows my mind. This was a severity of 10 out of 10, the worst you can have. I've explained to you a little bit of why the engineering of the hacking is so severe and why it's such a big problem for any level of enterprise. But unfortunately, we're not seeing the response that we would hope to see here. This is not coming from a place of ego. This is coming from a place of knowing that if 40% of most recent downloads, this comes from just a week ago, and it's stably, you can see this line is almost flat since February. If 40% of downloads are vulnerable, you're sitting with an entirely open surface area of attack for an injection, for an executing files that you're not aware of that will break the business value of what you're trying to build and provide to end users. And that's sort of best case scenario. You might have severe ransomware that they put in place. And if you've seen my other talks, some of the ransomware attacks that have gone out because of this have been really, really intensive. We need this number to change, not just in the Java community. And I think there's a couple of reasons for this. One, most of the awareness around Log4j really as a continuing issue is possibly in the Java community. But none of us have time to develop a new logging feature. This has impacted Rust. This has impacted Golang. This has impacted primarily Python projects as well. This is one of the biggest logging mechanisms that we use in the world. It's why, so the reason why Log4j is such a good vulnerability for a hacker is because it allows me to serialize all of the important information that I need when I'm trying to log a service. It's great. It's a good product. It's a good open source package. There's a reason why we still have it, we still need it, and why the maintainers make it available. But if you're downloading a vulnerable version when there are non-vulnerable versions available, you've got a major problem. The second issue here is not possibly just awareness. There's an added issue here of Log4j might be hiding in places where you're not able to do security analysis very well. It's hiding in jars and Uber jars. So you need to open those up, scan those, make sure that you're checking under every nook and cranny inside of your source code, and remove this. This is never not going to be a 10 out of 10 criticality. It's got to be removed. My final note here is that this is not specified to a specific nation, a specific area. We're seeing this issue across the board. This is not, and I have seen this narrative, so I need to call it out. Log4j is not something that's being specifically weaponized by any specific government. Every single nation and nation state is being impacted by this at variable rates. And we see this global map change in color depending on the week. It really is a matter of making sure that your enterprises, and yes, our like federal software systems as well, need to be secure here. But thankfully, mostly we're getting those under wrapped. So if you do ignore this, history will repeat itself. So there's going to be a lasting impact of Log4j. We've seen some pretty severe ransomware attacks, just nothing that's maybe made it onto your news screen yet, but it will happen, especially if we're still seeing 40% vulnerability. So the Struts vulnerability was announced in 2017, March of 2017. And one of the most famous cybersecurity attacks in the last 5 years has been the Struts vulnerability, because it was the cause of the Equifax breach. The Equifax breach was 6 months after this vulnerability was made public. They had all the information they needed. They could have updated. They could have moved to a different service, but they did not. And that was a business altering decision on their part to ignore cybersecurity as absolutely essential to software development. And this is what I really hope everyone understands here. This is so essential. You will not have a business if you ignore cybersecurity. It is not something that you can any longer do in a response to an incident. You have to do this predictively. So there's 5 stages of software supply chain maturity. There's unmanaged all the way up to monitoring, measuring. If you're interested in SRE and DevOps, you're probably more on the control and monitoring side already, or at least really hope to be. And we're going to talk a little bit about what monitoring, measuring can look like if we take an SRE approach to cybersecurity moving forward. So we've got the issue of what more monolithic or traditional architecture looked like. It used to be that you could, create a picture file basically that says exactly what APIs are going to hit different parts of my software architecture, and that would be stable for a good 6 months or more. That's not really any longer the reasoning that we need to be working off of. We not only need to consider good, sound, holistic architecture, but we need to talk about the micro dependency decisions that we are making on that. So how well do different components, but also the versions of those components from open source fit together? And are there issues with those? Now, if you think that you're doing this well, statistics are probably going to prove you wrong. So in 2021, we found that 69% of dependency management decisions were suboptimal. This means that when making the choice between 2 different versions of the same package, you're actually more choosing the package that is less optimal or more likely or verified already to be vulnerable. So 64 of these were imperfect decisions. You're just choosing a version that's, not the most up to date or has a vulnerability. 3% were non-subjective suboptimal decisions. These are making the worst choice possible out of a selection of versions. but 31% were optimal decisions. So making the right choice for not just the package, but the version of that package to use. And I really want to see that number moving. We need to see that number moving, because every time you have a vulnerability and you have to refactor based on that, you're losing time that you could be using for feature development and making something cool. So there's a couple of ways that we've been looking at how to make the right decision for an open source package. But being a machine learning engineer myself, I always lean toward quantification. I also lean toward quantification because it allows for good monitoring and observability. So there's two ones that I'll go over, and then I'm going to cover the new one in a little bit more detail. So there's source rank, which aims to measure the quality of software based on slightly more qualitative measures. So this is looking at project documentation maturity, community engagement. OpenSSF criticality is useful. And again, use a combination of these if you're trying to do good observability for cybersecurity in your systems. But this is a score that tries to show us the usage, community, and activity, but really more in relation to how much is it utilized by the ecosystem, how many enterprises is it sort of supporting. But I want to shift our attention to Mttu. So this is mean time to update. Now, this is something that I really want people to be considering now as something that you can use as a hybrid or combination SLO moving forward. So let's take that mental shift from being reactive of cybersecurity and using a quantitative metric that we can use in our dashboard reality of development to make sure that we're making the right choices up front. So mean time to update is a way of looking at individual packages and quantitatively knowing how likely they are to update their own dependencies. So you can have an Mttu for your own source code. You can also calculate an Mttu for an open source package. And all of this comes down to a really nice, clean average where you get to understand the overall health of your system. Now, when we're talking about averages, that means that we might be able to create a cybersecurity error budget based on your mean time to update, not just what you update, but the packages that you depend on. So for calculating the Mttu, it really looks like this. This might look confusing at first. It's actually pretty simple to understand. So we are looking at two different versions, version 1.2 and version 1.3 of an open source package, for example, or this could be version 1 and version 2 of your own application. We're looking at all of the components within it. So it is absolutely true that in this open source supply chain, typically open source packages are being pulled into the open source packages that you're pulling in. These don't have to be open source. These can also be proprietary packages that you're pulling in. Equally, it's important to understand how often they're updating. When we consider that there's been a 650% increase in cybersecurity attacks on the open source supply chain. So we want to calculate the time between when a version was released and when a second version is released with a new version of that dependency update. So really, this is talking about a hygiene where we are mitigating the likelihood for new cybersecurity concerns, vulnerabilities, but also inversely guaranteeing that we're typically getting the most up-to-date, the most functional code here. Now, I understand developers considering that, new versions do and can also break when we're at that sort of really cutting, bleeding edge. But that's why you want to have this as an Mttu error budget. Think of this in a lot of the way that you would think about uptime, right? You're never going to have a perfect Mttu. If you are, you probably aren't. You definitely can, because all of these packages are changing and evolving over time. Got a slide on that after this, but when you're computing that average, you can define what you're comfortable with and what you think is going to mitigate risk, moving you from responding to security incidents to creating a preventative quantitative strategy for it. And this is what's really cool. So when I was asking you all to consider moving from monitoring to observability, I really want you to have those composite SLOs that are meaningful. A really, really common SLO that a lot of you already have in place is your mean time to remediate, your MTTR. That's important. That's something that you often have service level agreements around. But Mttu is strongly predictive of MTTR. And this is the most exciting thing that I found in our entire analysis of this. So this means that I'm not selling you a story here, I'm telling you the truth. It is the case that your mean time to remediation is really strongly and kind of primarily influenced by the issues that we're seeing from the open source supply chain. So let's develop ways of observing that so that when you can combine a dashboard that shows me my mean time to update and my mean time to remediation, I'm looking now at a very site reliability engineering kind of end-to-end process of having two numbers that tell me the health of what I'm intaking and how easy it is for me to fix a problem when it finally does come in. And that ratio, that understanding, that relationship gives you an ability to now be observing predictively the way that we want to be doing open source moving forward, because you need to have that plan of attack, that plan of engagement, a way to be creating this immune system around your source code to be able to deal with the new supply chain attacks that we're seeing coming in. And this is really the final point here, and this is why you can't ignore this. So mean time to update, when we looked at mean time to update across open source packages for an ecosystem, it used to be that about 10 years ago, it took a little over a year to get to a new version update. Now, in 2020, it took about 2 months in order to put out a version update. The reality of this is that we are seeing new and interesting development. We're seeing subcomponents of open source being able to work together. We're seeing human innovation. And this is really what this means. This is human innovation accelerating in a way that we can quantify, because we're seeing new packages, new ways of thinking, new machine learning, new really incredible development here. And when we're tracking that MTTU improving, it means that, yes, we want to be aware of this inside of our own source code, but it's not as if you didn't track this, this wouldn't already be happening. All I'm trying to do is get you to build a dashboard that is more representative of reality so that you can respond to reality, so that you can predict reality in your development process. So this is exactly what I said. This is really what I want you to take away here. And I'd love to hear from developer teams that try this. Telling a composite story with SLOs is one of the tried and true best practices from SRE. Let's steal that best practice in the same way we'd steal a good open source package. Let's use mean time to update and mean time to remediation and see if you don't see a strong, possibly, I can tell you statistically, predictive relationship between an MTTU that's healthy and mean time to remediation that improves. This is the best way to build not just an end-to-end understanding of your own source code and DevOps process, but actually involve those 9 out of 10 developers who are not on your payroll. This is a metric which allows us to observe the health of development from a space of engineering and open source that you have no visibility or awareness or communication with often otherwise. But when you track the MTTU, you know implicitly how healthy the open source packages that you're pulling in are. And when you're doing that, you're going to make much better choices around what you're bringing in, know where you're dealing with a little bit of risk, and be able to reduce that time to remediation in ways that we really haven't seen before. This is a really new way of doing cybersecurity predictively that I'm excited about. So this is kind of the argument that I'm making. So it is true still, and this is my opinion, that there is in a lot of enterprises, a separation between DevOps and SRE, but I like to claim that it should look a lot like this, and it does, in practice, look a lot like this. So SRE really should be working more in that monitoring and operating and deployment aspect. Open source security should be more on the development side. Now, if you're asking me, how do we do this? We've just got a bunch of pen testers. Let me give you a reason why I think this can change. So I promised you that I would give you a lot of information, and I know that some of this talk has been scary, but I think this can also be fun. I have been both an open source maintainer and contributor, and I have also worked in enterprise. It's important to me to make sure that we are doing this in a way that people enjoy, because it's not true that your developers are just going to sort of walk away. In reality, when developers get bored, they're just going to go work on their open source package that they've been working on as a side gig. So if we want to be able to support and make sure that MTTUs can be healthy across the board, how are we going to do that intelligently? How are we going to start supporting that 9 out of 10 developers that are contributing to your source code? This is how I want us to do this. And so this, what we're looking at, is a very basic model in any given ecosystem of how open source works. So you'll have a given open source project. Typically, this is sitting on GitHub or GitLab, more likely GitHub. So you've got a repository of their code that you can pull from, contribute to, give issues to. And you have a maintainer or a set of maintainers that have full access and editable rights to that code. But you typically have a big community of open source contributors who are both providing ideas for features, but also really contributing genuine code contributions to that project. We're always doing our best to make sure that the maintainers and open source contributors can work together to facilitate the best progress around an open source project's feature map. But cybersecurity has not traditionally been a part of that approach. And that's because it's sort of had this siloed identity in enterprise. So this is where bug bashes come in. And I'm going to explain this to you as something that we do for open source, but there's no reason why you can't do this in your own enterprises and on your own developer teams. So a bug bash is something that brings developers together in a live, asynchronous, and cooperative model to find and fix as many bugs as possible on open source projects. So I mean that specifically in this case to state an open GitHub repository is what we can run these over. So typically in best practice, if you're running these well, you'll do this over a short time period. So I've run these either over the course of a sprint or over a conference, for example. A online conference is a really good example of this. And you will typically get a backlog of bugs using different SEA analyzer tools. But more importantly, you gamify your community. So either your open source community or you bring in the larger cybersecurity community. You gamify it so that you make sure to remove cybersecurity concerns from those open source packages that we all rely on. So this is what this looks like. You put a bug bash over an open source repository. Now let's think about where the business value is for this if you're an enterprise. Look at the MTTUs of the packages that you are depending on. If you have something that your architecture absolutely cannot function without, like Log4j, for example, consider hosting a bug bash to make sure that you are supporting for some period of time, removing the security backlog around something that, if fails, is going to be a business limiting issue for your software development team. So this is not an act of altruism. This is really driven by business value. If you understand open source in the way that I've tried to explain it to you, that problem's not going away anytime soon. We need to figure out a way to support the full life cycle of open source. Now, thankfully, I've made this really easy for you because we've got a tool that does this. This is free and open source, and this will always be free and open source. And this is Sonatype Lift. So this is a cloud-native collaborative code analysis platform where we have put together every static analysis tool that we could find or create. We've also provided a bunch of extra bonuses in there. So you've got a bunch of linters, which are really going to help to clean up your code. We check out licensing. We basically are supercharging and providing what looks kind of like a developer team inside of a tool to open source repositories. And so this can be an open source package you depend on or your own. Now, I'm giving a couple of examples of projects that we have been working with. I particularly am a Kubernetes and machine learning engineer, so I focus on the Kubernetes space. These are some of the projects that I have supported in the sort of just in the last 6 months or year. And we're running a new bug bash in this exact same model for KubeCon in May. So if you want to participate, it's going to be fully remote. It's going to be a cool way to learn and understand more about modern cybersecurity concerns. But this is what's really, really cool about it. And this is why I love this. Well, I love it primarily because it's free forever and open source, and I'm all about that. More importantly, this is about taking cybersecurity from what was really shifted far right and just like trying to do pen testing on your source code or trying to alleviate concerns after they need to be resolved. What this does is as soon as it's installed, it goes through your entire code. It gives you a backlog of things that you can address, bring your community in. But way more importantly, every PR that comes in after that is going to be scanned. So it's quick, doesn't take very long, but it tells you whether or not that's something that you should merge or not. It tells you whether or not that's something that was intended to be malicious or has the potential to be malicious. So this is a really cool way of using tooling and automation to be able to bring a new kind of observability into your development pipeline. And you can deal with it and address it in real time and see exactly where it is in the code. And that is so powerful. So we've got, I mean, this was 24. We've got more than 24 pre-configured analyzers before sort of in place now, and we're improving this all the time. And again, this is what's so cool about it. It's the get clean, stay clean model. So it's very cool. We have major open source projects that we all depend on. When they participate in some of the bug bashes that we host, we make sure that their security backlog is clean and that they're good to go. But when we're looking at this as a model moving forward, using these kind of tools and this way of thinking is going to improve Mttu across the entire software delivery system. And it prevents us from having those backlog headaches, right? There's a reason why Mttu is strongly predictive of MTTR. It's because of issues like this. And if we solve this in real time, where developers care about it and are going to see it, again, that's right in our PRs, then we're going to solve the problem. And lastly, it's a good idea to gamify this. So when we run these and we host them from Sonatype, again, we work a lot with Linux Foundation and particularly with CNCF on this. What's cool about this is we bring in people who may not be traditional contributors to open source, but are super strong in cybersecurity, because we provide them an alternative possibly to some of those like HackerOne motivational models around just money. We provide them the ability to be stack ranked in the value that they're giving to these open source communities. We, talk about, instead of just switching the model from making people aware of vulnerabilities, we're now shifting the motivation and the culture around open source to preventing and solving vulnerabilities. And in a world where a lot of times you're seeing these sort of vulnerability bursaries are getting reduced, there is less of a financial reason for individuals these days who are really strong in cybersecurity, and particularly on the ethical hacking side. Ethical hacking, I genuinely think, has kind of seen its day and age in being something that people are motivated by. It's a lot more financially viable in some cases to be a black hatter than a white one. In this case, we need to be thinking about how we can take the incredible human intelligence, the incredible time, the incredible capacity of these hackers, and move them towards a model of seeing what can we do to be able to make open source something that really works for everyone. Yes, it's a good idea to still do pen testing. It's a good idea to go in and have some of these motivational models, but flipping that around and thinking about this in the context of everything accelerating. Your open source packages are accelerating, your own development is accelerating. Do something like a bug bash. Lean on the bug bashes that we are making available for you to utilize. Make sure that you're shifting the awareness across your organization to prevention in cybersecurity. So I did my best to try to get this sort of cut down. I did speak fast, so I will take any questions. But there's a couple of things that I really want us to take away from this. Number one, we learned a lot about the modern adoption of cybersecurity practices and how the incorporation over the last sort of decade culturally to developers of site reliability engineering is something that we can totally lean on and should be leaning on as a model for engagement and communication in enterprise for cybersecurity. And all of that is central to monitoring, observability, automation. All of that genuinely breaks down into having a predictive system that you can depend on. That is good dev culture. That is real quantitative trust in the developers around you and in the system that you're building. Second, malware attacks in open source have and will continue to exponentially increase. This is why I'm working on this problem right now. It's huge. It impacts everyone. Again, they're not aiming for the big enterprises anymore. If they can hit something like matplotlib, they can have a massive surface area and they can attack anyone from the weekend coder to a major enterprise. And third, this really can be fun. This is something where if we align the motivations across DevOps, SRE, and cybersecurity, we're going to start to see a much more functional process. We're going to be able to see that acceleration without stalling because we get that mean time to remediation down as much as possible. And it can be fun. You should try doing bug bashes in your own organization. Reach out to me. I'll provide some resources. Let's figure out how to do this. Make it make sense. Support the open source packages that support your source code, and make sure we're moving into a future that we all believe in and want to participate in open source. So I really encourage you to check out Sonatype Lift. These are some of the primary ecosystems that we are working with. So if your application is dependent on these, absolutely worth giving a try. I will say we are definitely far and beyond really interested in talking to really Java-based applications, just because the intelligence that we have is world-class for that. But we are working with every single major ecosystem. So even when, we address and remove issues in Java packages, we also have a direct relationship with PyPI where we inform them and help them to remove dangerous packages before they can ever get into your source code. So I hope we can just have a moment to recognize that cybersecurity is changing. We at Sonatype are doing our best to do what we can to support the communities that we're all dependent on. And everyone, I think, needs to sort of take a step back and see what their role can and should be and what the future looks like of development. So a couple of good links to be able to stay in the know here. So a lot of the statistics that I pulled from were from the State of Software Supply Chain 2021. We've got a new one coming out in a couple of months, and I'm really curious to see how things have changed. What I showed you at the beginning there when I was trying to explain to you that Log4j just had really good PR, but there are a lot of other issues going on, that was from the vulnerability timeline. I really encourage you to check this out because we've got great security researchers, and this gets updated every single week. Lastly, some of those Log4j statistics that I showed you, if you're curious and concerned about whether or not you have Log4j in your system, go check out the Log4j Vulnerability Resource Center. It's going to show you the real-time updates globally. It also gives you a free resource to be able to go through and scan and see if you do have it. And then Sonatype Lift. So this is a free resource that you can use with the best of the intelligence that we can provide. You can use this on any open source repository now. And it's pretty easy to install and get engaged with. If you want to use it or are currently using it, I'd love to hear from you. I am in touch with a bunch of maintainers and developers who are actively utilizing this, who are shifting their mindset to put security all the way left in their development process, all the way into their PRs, right? That's a real game shift here. And Lift lets you do that. So if you want to give it a try, just go to lift.sonatype.com, getting started. And lastly, if you want to get in touch with me, I can always be found on Twitter like the rest of the developer world can as well. You can find me at Kimmich_compute or find me by Sal Kimmich. So with that, I will stop sharing my screen and see if we do have any questions.
So we did receive just a couple questions, but I'll go ahead and take this opportunity to ask our audience to go ahead and send in any questions that you might have while we go through these first couple. So Sal, the first one is there a limit to how many role-based training modules you can have?
I think a little bit of context around this would make sense. But so rule-based training models in this case. Honestly, my sort of feedback here is yes and no. I think all that I want to say here is I've seen a hyper reliance on false conditions, just, sort of going after a table talk or a game day. But yeah, I would limit these to something. There's one of two issues. I would limit these to be something that you do maybe a couple times a year if you need to. But I'm also sort of making the argument here that the way that the software supply chain has changed, the way that sort of vulnerabilities come into place, specifically for cybersecurity, you don't really need to be doing tabletops anymore. The real condition is going to hit you, and you don't want your developers to be fatigued. So it's kind of like the fire alarm issue, right? Am I pulling or sort of doing a test of the fire alarm, then people don't care when it comes? That's really kind of what we're seeing with Log4j. This is a real condition, a critical 10 vulnerability, but I think people are so fatigued by it that they're not engaging with it. So yeah, that's something that you sort of have to make a culture call, and you have to understand how severe are these issues in your architecture. But again, just make sure that you've got a pretty good SOP in place. That's the point of those. The point of those is not to prevent, to imagine dragons and to slay those imagined dragons. The point of doing those practices is genuinely for operations. How are we going to externalize and communicate this? And as soon as you've got that into place, you want to put all of your effort, all of your developer time into reducing that error budget or widening that error budget, but making sure that you're just delivering value.
Awesome. Thank you, Sal. So our next question, it's a little bit of a long one, so bear with me here, but what is the difference between open source CVE risk and CVE for a closed source commercially licensed critical component, like say an RSA library?
All right, good question. So in this case, both of them are problems for you. So like the CVE scoring is about the criticality of the impact, right? So it really is sort of the fundamental issue here is you might have some more observability in the open source package as to like what the changes are being done. Although open source maintainers are getting more creative about making sure that they make these changes in a way that doesn't disclose it to hackers while they're trying to solve the problem, which I appreciate. But really, we're sort of just fundamentally talking to the difference between open source and closed source or proprietary. So in that case, you may not understand what the changes have been made in order to reduce a vulnerability or remove a vulnerability for proprietary in a way that you might be able to observe in an open source project. But this is key, right? You only enter a proprietary engagement with a contract. These contracts for not security, for any SaaS, for any software project come with SLAs. So the fact is, you probably do or should have a legal agreement that, right, if they do not remediate a severe criticality in their software that you depend on at a rate that you are comfortable with, at a risk that you are comfortable with, then yeah, you legally are not, in some cases, required to pay them for that service. But that is part of why engineering teams have trended over time towards working with open source, because it's a much more communicative model, and there's a bit more of a guarantee by having that observability.
Well, thank you for that. So, Sal, I'm not seeing any more questions that have come in. There were lots of comments during today's discussion, so feel free to go through and look through those. But we have exhausted all the questions for today, so I'll go ahead and give you the floor one more time in case you have anything you'd like to say before we wrap up.
Yeah, sounds good. I'm just doing like a quick, there's a lot of comments, so I can't hit all of them. But I do just want to do a little bit of a retouch on MTTU. So is MTTU a principal component of MTTR? It is not. And this is what's so cool. They are completely different quantitatively. So MTTU is, right, a metric that tells us how often the open source components that we depend on are updating. And conversely, we can use an Mttu in order to understand how often we are updating from open source packages that we're pulling in, right? We're just making sure that we are capturing the acceleration of development from that sort of 9 out of 10 developers. It's completely quantitatively different. It comes from a different source from MTTR. So MTTR is just the time that it takes for you to remediate from a issue. But this is why it's so interesting. There's a lot of reasons why you might have a good or bad mean time to remediate. But the fact that MTTU is so strongly predictive, for me, indicates that a lot of the issues that we're seeing with development are not sort of cultural, communicational, operational. They're from the supply chain. So if you create a composite SLO that allows you to observe that sort of end-to-end, where it's not just your enterprise that you're considering, you understand that your enterprise is the size of the globe and it's the size of whoever wants to contribute to Python or Java or Golang. That metric is going to help you to make sure that your source code is healthy, and healthy source code make sure that your MTTR is reduced. So I just wanted to make sure that I could clarify that. So MTTR is a pretty common KPI of DevOps. I know there's a lot of acronyms here, but MTTU is new, right? And it's only this global holistic understanding of the supply chain that's really gotten us to this new statistic. And I want to see more people using it, because mean time to remediate means you've got more developer time to accelerate and build new features and, change the world with software. That's what I want to see. So with that, that's all I've got.
Well, Sal, I really appreciate you taking the time and coming onto the webinar and really going into depth about all of this. For me, I hear a lot about Log4j being on these webinars each day, but I'm not hearing a whole lot about what exists outside of the Log4j. So absolutely eye-opening.
Absolutely. All right. Well, thank you so much. And thank you everyone who joined.
Thank you, Sal. So I'd like to remind our audience that this session was recorded. So following this workshop, you'll receive a link to access the recording on demand. You'll also find it living on the Security Boulevard website at securityboulevard.com/webinars. We do have 4 $25 Amazon gift cards to give away. Our first winner is Benir P. Our second winner is Stan T. Our third winner is Kapil A. And our fourth and final winner is Hiroatsu I. So congratulations to the 4 of you. Keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. I'd like to thank Sonatype for sponsoring today's workshop. And last but not least, my final thanks goes to you, our audience. We really appreciate you taking the time out of your day to be here with us. Please take a moment to look at our upcoming webinars. We've got plenty coming up, and we hope to see you at one of them. This is Cody J. Brown signing off. Have a great rest of your day, everyone.